So, salt hydrolysis is looking at when salts dissolve in different solution, and we're going to talk about whether some salts make a solution acidic or basic, and it's all based on the conjugate ions that are formed from dissolving the salt, looking at whether they're strong or weak conjugate ions of an acid or base. So, an acidic salt solution consists of the anion of a strong acid and the cation of a weak base. So an example here is ammonium chloride. So the anion of the strong acid is the chloride ion. Hydrochloric acid would be the acid that forms that anion, meaning it's strong and thus dissociates completely, leaving all of the hydrogen from hydrochloric acid existing as hydronium in the solution. Whereas the cation of ammonium here would be in equilibrium and would form some of the weak base, but not all. We're going to look at a few different equations where I can explain this with the help of the actual equation in front of me. So a basic salt solution is the opposite. It consists of the anion of a weak acid, so that anion is in equilibrium with the weak acid, and the cation of a strong base. So sodium is another good example because sodium hydroxide is a strong base, and the sodium would dissociate completely, leaving all of the base in the solution. When a positive or negative ion react with water to produce an acidic or basic solution, you have this happening. And think of this for a second. Will aluminum ion make this acidic or basic? And it's acidic because the aluminum will remove some of the hydroxide from the solution. And in this reaction where aluminum reacts with the water, aluminum hydroxide will often precipitate, and you get a production of more of the hydrogen, which would then create hydronium, lowering the pH and making the solution more acidic. So general cation hydrolysis rules: you're going to have most metals making acidic solutions, often because what we just looked at with aluminum, lots of common metals with 2+ or 3+ charges form stable hydroxides, thus precipitate some of the OH- from the solution. No group 1 or 2 elements form stable hydroxide except beryllium. Those are like the alkali and alkali earth metals. So metal oxides will also make basics. So I said also. Metal oxides will make basic solutions, is another general rule. Here let's look at a few. So salt formed from a strong acid and a strong base will not hydrolyze water. Look at the simple reaction between hydrochloric acid and sodium hydroxide. Take the chlorine and the sodium ions that are produced from this salt, and you would get hydrochloric acid and sodium hydroxide in the hydrolysis of water. But this does not happen. Okay? Because the acids and bases dissociate completely, the chlorine and sodium ions would be surrounded by the water molecules and not form those acids. There's no equilibrium equations there. So this example versus something where you have a weak acid or base will hydrolyze in water. So this is an reaction where you would have your acetate ion as the conjugate of a weak acid and your sodium ion as the conjugate of a strong base. Taking both of those ions and reacting them with water, in the first reaction you have an equilibrium reaction. So some of the weak acid is formed and you have that excess hydroxide. And this reaction with the sodium here, so this is some of the weak acid forming when you hydrolyze the conjugate acetate ion and you get more hydroxide forming. And the sodium here, this reaction again does not occur because strong acids and bases dissociate completely, but weak acids and bases don't. So this equilibrium reaction occurs. And that is salt hydrolysis.